Hello class, today we're going to do the first part of a two-part lesson on similarity. Okay, so first question I have for you is, what do you remember about similar figures? Okay, you should remember about four things. Okay, there are four things that we know about similar figures. They're the four main characteristics. They, one, have to have the same shape. Two, they're going to be of a different size. One's going to be bigger than the other one. Number three, corresponding angles are congruent. And number four, corresponding sides are proportional. The last two are the two big ones that we need to focus on today. Now, why are we doing this? Well, because one of our standards, and this particular one is a 7th grade standard, we have to understand this particular thing in order to do the 8th grade stuff we'll do later on in the week, dealing with transformational geometry, is we need to generalize the critical attributes of similarity. In other words, we need to understand these four characteristics. So by the end of this lesson, you should be able to take two shapes and determine, are they similar? Okay, well, one of the first things that we have to do to figure out if two figures are similar is be able to determine if ratios are equal or not. Okay, so if we were to look at these first two ratios, 16/6 and 40/15, okay, one way in order to figure out if those two ratios say the same thing or say the ratios are equal is to cross multiply. Take the 6, multiply it by the 40, take the 15, multiply it by the 16, and if you get the same answer on both of those, then these two ratios say the same thing. Okay, so if we were to multiply 6 times 40, I would end up with 240. If I were to multiply 15 times 16, I would also get 240. So we can say that these two ratios are equal to each other. Okay, another way you could do it is you could take your calculator and just do 16 divided by 6 and 40 divided by 15. If you get the same answer on your calculator for both of those, then we know that those two ratios are equivalent. Okay, if I were to look at number 2, okay, on this one right here, we've got one other way of looking at this one. We could ask ourselves, how did I go from 3 to 18? What would I do to 3 in order to turn it into an 18? Well, we would multiply it by 6. So in order for these two to say the same thing, I would need to multiply the 8 by 6 and get 48, not 46. So we know that these two are not the same. And if we did the same thing on number 3, that's how we could test this one. What could I multiply 8 by to get 24? 3. So 9 times 3, does that give me 27? Yes, it does. Okay, so one of the skills that you have to know how to do in order to determine similarity is tell whether or not two ratios are equal to each other. That's one of the things we'll do in this lesson today. So the overall objective for our lesson today is to learn to use ratios to determine if two figures are similar to each other. There will be 3 vocabulary words that we're going to work through today: similar, corresponding sides, and corresponding angles. So if we were to look at this one, it's talking about octahedral fluorite. It says octahedral fluorite is a crystal found in nature. It grows in the shape of an octahedron, which is a solid figure with 8 triangular faces. The triangles in different sized fluorite crystals are similar figures. Similar figures have the same shape, but not necessarily the same size. And that's one of the first two critical attributes that we discussed: same shape, different size. Okay, and that's what we need to understand about similar figures. Okay, so one other thing that we need to know about is corresponding parts. It says matching sides of 2 or more polygons are called corresponding sides, and matching angles are called corresponding angles. Corresponding means in the same place as. So if I were to look down here at these two shapes, here I have angle A. Well, that's in the same place as angle D in this other shape. So we would call those corresponding angles. And notice these angles are the same: 43 degrees, 43 degrees. Angle B and angle E are corresponding parts. And angle C and angle F are corresponding parts. Okay, so we have to understand the idea of corresponding angles. Now let's talk about corresponding sides. Here we have line segment AB, and the way we would write that is we would do AB with a bar on it. Well, that corresponds to or is in the same place as line segment DE over here. So we would say that those are corresponding parts. We would also say that BC corresponds to EF, and line segment AC corresponds to line segment DF. Okay, and that's how we identify the corresponding parts. Now, one of the things that we need to understand about those is they do have to meet certain conditions. Corresponding angles must be congruent or equal, and corresponding sides are proportional. So we'll get into the proportional part here in just a few moments. Okay, so let's move on. So when naming similar figures, you're always going to list the letters of corresponding vertices in the same order. So take, for example, this says triangle ABC and triangle DEF. The A and the D have to be in the same spot. The B and the E have to be in the same spot. And the C and the F have to be in the same spot. Now we need to talk about this little symbol right here in the middle. This little symbol is a squiggle. Well, what it stands for is similar. So anytime you see that little squiggle, and when it's by itself, we would read this as triangle ABC is similar to triangle DEF. Now there is one other symbol that has the squiggle on it, and that's the squiggle with an equals. And that one means congruent. Okay? So, but if it just has a single squiggle, that means that they are similar, which means they meet those 4 conditions that we talked about a few moments ago. Okay? Now, similar figures. Here are the 2 big pieces that we need to understand. Okay? The measures of their corresponding angles are equal. Okay? So corresponding angles must be congruent. And then the ratios of the lengths of the corresponding sides are proportional. And that's going to be the big one that we'll talk about in just a moment. Okay? Now, the other thing is this naming procedure. It says a side of a figure can be named by its endpoints with a bar above it. So that we would read this as line segment AB. And we're talking about the actual side itself. If I don't put the bar, without the bar, the letters indicate the length of the side. So we would say AB is equal to 5 inches, that kind of thing. Now, for the remainder of this lesson, we're going to try to determine, are these 2 shapes that you see, are they similar? So if we look at triangle ABC and triangle DEF, we need to determine similarity. So the first thing we look at is we look at its orientation. You'll notice that this one kind of looks like it's upside down and this one's right side up. All right, well, we know that line segment AB corresponds to one of the pieces in the other shape. Well, what piece does it correspond to? Line segment DE. And we would write that just like this. Line segment AB corresponds to line segment DE. Well, in order to determine similarity, we need to set the side lengths up as a ratio. So we would take this 4 and we would set it divided by 16. All right? We'd do the same thing for the rest of them. So we got line segment BC would correspond to line segment EF. So we would have 7 over 28. And then we would have the last one of AC and DF, which is 10 over 40. And what we would want to do with this is to determine if they're similar is they all have to say the same ratio like we practiced in that warm-up earlier. So we could take each of these and we could cross multiply them to see if they worked, or we could just figure out 4 divided by 16, 7 divided by 28, 10 divided by 40. Okay, if we do all the division, if we get the same answer on the calculator, then we know that they are similar. We could also just ask, what could I multiply 4 by to get 16? 4. Could I do the same thing with the 7 and the 10? 7 times 4 gives me 28. 10 times 4 gives me 40. So we know that these 2 shapes are similar to each other. Okay. So what if I gave you these shapes? We've got some quadrilaterals here. We need to determine, are they similar? Well, the first thing we look at is corresponding angles. Are they the same? Well, we'll notice that 80, 80, 65, 65, 125, 125, 90, 90, all the angles work. But now we need to figure about the corresponding sides. Do they have the same ratio? Okay? So what we would do is we would write out our side lengths. MN corresponds to QR and NO corresponds to RS. And we would write out all the ratios. 6 over 9, 8 over 12, 4 over 6, 10 over 15. And each of them simplified down to 2/3. Or if we did it on the calculator, each of them would give you 0.666666667. If they all give you the same answer, then we know that they are similar. Okay, so answer this one on your own. Pause the video and determine, are these 2 shapes similar? Okay, let's see how you did. Well, the first thing we do is we look at all the angles. Are they equal? 80, 80, 90, 90, 65, 65, 125, 125. Hey, they all work. So now we're looking at the side lengths. Now this one you could just do in your head if you wanted to. 100 times what would give me 400? 4. 60 times what would give me 240? 4. 80 times what would give me 320? 4. 47.5. I don't know that one. Okay, well, take your calculator, you multiply that by 4. Does that give you 190? And it does. And if you look at all the angles and you match all the sides, okay, if it all works, then we know that they are similar. Okay, and that's the big thing about similarity. Our corresponding angles must be congruent and our corresponding sides must be proportional. So let's kind of finish this up. Let's just answer a couple questions. Let's just see. We have number 1 here. It says, are these figures similar? So step number 1, look at your angles. 59, 59, good. 86, 86, good. 35, 35, good. Okay, my angles are good. Now I'll look at my corresponding parts. Here I've got 4 and 8. What did I do to 4 to turn it into an 8? Multiplied by 2. So can I do that to the other 2 pieces to find out whether or not they are similar? So I've got this one is 7. So the other corresponding part should be 14. There it is. This one is 6. The corresponding part should be 12. There it is. Are these figures similar? Yes. Okay. What about these two? Again, we check our angles. We start off. Here's a 107. Here's a 107. Excellent. Here's a 119. But here's a 135. So these are not similar. And that's what we're looking for similar shapes. So there's 4 characteristics that we need to understand about similar figures. 1, they do need to have the same shape. Not the same orientation, but the same shape. They're going to be different sizes. Okay, so those are both our visual kind of cues on these characteristics. But the last 2 are mathematical. Corresponding angles must be congruent and corresponding sides are proportional. And that's how you determine whether or not 2 figures are similar.